welcome back. So this is a recap of today's stream. So as usual, I will start with a recap of the recap. So for that, I'm actually going to go down or go back in history or hit history. And so this was the code that we had at the end of last week's session. I'm just gonna run it, and then while it runs, because it takes a while. So we did all of these imports, and then we had selected the RGI, human gut. We load the data, and we select genes that appear between 20 to 80% of the samples. And then we had built a heat map of how many times these genes co-occurred. So when we had then used hierarchical clustering to reorganize the columns and the rows so that in the heat map it will be apparent once it's finished computing in a few seconds that there are these clusters that appear. And I had commented that this code here that loads the data actually here, this code probably should be extracted out and made into a separate function, because so far, this is just a script that runs from top to bottom, but as it gets more complicated, I was going to start to reorganize this into chunks. And this, did the image not appear? Something here wrong. Oh, sorry, it was just on the other screen. Yeah, there it is. So we had seen this chunky block nature, which indicates that there is some structure here. Right, so let's get out of here. So this is where we were. Let me just check. Yep, this is where we were at the beginning of today's session. And then today we started indeed by first building this load data function where we've extracted now the loading code. So here everything same as before, except we extracted it into its own function. And then we saw that there's this piparg has a slightly different file format, so it needs to be special cased, but then everything else looks the same. Then one of the advantages of this is that it allows us to very easily write a test, here using the exact format that PyTest requires, which is simply that things we call test underscore. It's a very lightweight way of doing things, and then I can use PyTest, and it's going to find the test and run it. In this case, there's only one test, and then these are so-called smoke tests because they are very basic in the sense that if they run the code and then they check that, in this case we just check that the number of outputs, the shape of the outputs is what we would expect it to be, and then in this name smoke test comes by analogy to in construction. So if you have a pipe, if you blow some smoke into the pipe, if the pipe has a big hole, a big leak, then you will see smoke coming out of your walls, and that's bad. But at the same time, if your pipe has a small fissure, it might not be apparent in the smoke test. So you'll catch some gross errors, big mistakes, but it's not designed to catch very big or very subtle issues. So then I'm just gonna start running it so that everything runs. And so then we took the same code as before, except we adapted it. So here now, first of all, it calls load data as a function instead of having the code to do it each time, and then it's going to loop over all of the possible tools. And here you can see that the tools we have considered so far, most of them actually have very few genes. in this 20 to 80% range that we were interested in. The exceptions are actually deep ARG and RGI. Maybe ResFinder FG. Oh, no, sorry, deep ARG and RGI, where you have a few hundred of these. And then we output these plots here. You can see all of the different plots. And you can see that you see these structure, these blocks. And so what we said we're going to do next week is we're going to start digging into these blocks and seeing what they are. So it's possible that some of these are not that interesting if they are just blocks of genes that are known to act together. Maybe that's just what it is. But we will look. And so in the case of RGI, so this RGI uses the CAR database that comes with Arrow, which is the antibiotic resistance ontology. And so that will provide us with more information, because the Arrow, not only will we have some gene names, but we will have information on mechanism, which antibiotics they provide resistance to, if that's annotated, etc. In the case of deep ARG, we will actually do the same thing, but we need to have an intermediate step, which is to map from deep ARG to Arrow, which we will also do. So we then also discussed that over the longer term, we are going to eventually look at isolate genomes. So everything we've been doing here, we're looking at metagenomes. We have this GMGC annotated dataset close at hand. So this makes a lot of sense to look at. It also makes a lot of sense to look at isolate genomes, and so that will be in some ways a completely different line of inquiry. And then hopefully, if they will eventually merge, and we'll have some conclusions that are across these two different ways of looking at the questions. Right. So that's what we had. So if we'll continue next week. If you have any questions, anything, you can obviously always show up on the mailing list, show up on the Discord channel. Otherwise, I will see you here next week. Take care.